Hi, we're a multidisciplinary senior design team from the Kate Gleason College of Engineering. We're working on an ongoing project that's been going on for several years now. It is the Black Soldier Fly Larvae Composting Smart Shed.
This is our team. We have Riley, who is the project manager and the biomedical engineer. We have Tommy, who is the bin design master and mechanical engineer. We have Shams, who is the software manager and the computer engineer. We have Shaz, the mechanical engineer and the shed connoisseur. We have Aristo, the purchasing agent and mechanical engineer. And then we have, of course, our larvae, which is our composting master. What is our problem? Our problem is, as the population grows, the complexity of managing waste increases. Discarded food represents a large part of landfills within the United States. The problems associated with landfills are extended lifetime of landfills, which are associated with space being occupied, high tipping costs, and environmental impacts due to off-gassing and transportation of heavy wastes. On the left-hand side, we can see a map of the amount of craters of wastes in the United States. You can see that there is a large abundance. On the right top shows the landfill that we're talking about, and on the bottom is the tipping costs associated with waste transportation. And you can see it has grown a lot throughout even a year time span. How do we combat the problem? Well, this is our solution. We're going to use these little fellows called black soldier fly larvae. The use of the larvae can address the multiple problems associated with the landfill process. First, the ability to process a wide variety of food waste, thereby reducing the volume of the waste substantially. They also rapidly decompose waste. Second, they contribute to a significant smaller processing footprint. This addresses the problem of environmental impacts. Third, they can be used as incoming feedstock. The fattened larvae can be processed into animal feed, biodiesel, or biogas. This can be used as an income source and eliminate the tipping cost. This is an example of how the black soldier fly larvae decomposition would go. The leftover food would be given to the black soldier fly larvae. The larvae would then decompose the food, and the resultant would be biofertilizer residue, which is called frass, as well as the fattened larvae can be then composted into biodiesel, human feed, or animal feed, and then given to the animals. And this process shows how this can help reduce the landfills.
The client's vision is to improve the design of a scalable, semi-continuous black soldier fly larvae bioreactor in a controlled environment where the temperature, humidity, ventilation, and energy usage are recorded and monitored. The image in the middle is the current shed in which our current bioreactor is housed in. The image on the right is the current bioreactor. It is able to process 100 pounds of food waste per week. We have been given the 500 pounds of food waste per week. Some key issues to address for our team are larvae migration and collection, soil moisture control, rogue fly management, as well as enhancing the manufacturability and replicability of the bin design. Some control system requirements that we have been given are implementing the control system and monitoring systems into the shed, as well as developing an operator interface. Our client's vision is to implement this into residential neighborhoods and restaurants so that we can tackle the previous problems on a larger scale. Our team's solution is to have a easily manufacturable bin composting system that streamlines the composting process. The design is intended to be easily replicable and able to process up to 500 pounds of food waste per week. To accomplish this, our team developed a closed-shelf composting bin system that is able to have multiple composting shelves, allowing for easy expansion. The design has a gutter system to ensure collection of larvae, and the composting bins will sit on top of a mesh. Underneath the mesh is the frass collection bin. The customer will be able to slide the bin so that the frass gets separated from the larvae, thus improving the larvae management of the system. The control system has been designed to monitor and maintain the internal temperature of the shed and humidity levels. Our team's expected results are to accomplish certain client goals, such as the completion of the control system in the shed. As seen on the images above, the UI is currently functional. We are working to make it operational. Furthermore, the new composting bin system is expected to be fully built and operational. However, this system will likely only be able to process 200 pounds of food waste per week, but will have demonstrated scalability since more shelves can be easily added onto the system. Currently, the bin isn't fully built, but it should look similar to the cab models shown in the previous slides.